Diazines. EI stands for 2, AZ stands for nitrogen, INE stands for a 6-membered ring system. So, diazines. Di means 2, AZ nitrogens, 2 nitrogen atoms. INE indicates a 6-membered ring system. So 2 nitrogen atoms in a 6-membered ring system. So if we consider pyridine contains 1 nitrogen atom. This diazine contains 2 nitrogen atoms. These 2 nitrogen atoms may be in 1 and 2 positions, which are called as 1,2 diazines. So this is called as pyridazine. This unsubstituted diazine is called as pyridazine. Similarly, 1,3 diazines, 1, 2, 3, 4, 5, 6. The 2 nitrogen atoms are in 1,3 position. This compound is called 1,3 diazine and it is called as pyrimidine. Next, 1, 2, 3, 4, 5, 6. The 2 nitrogen atoms are in 1,4 position. Therefore, it is 1,4 diazine, which is called as pyrazines. So all these diazines, 1,2, 1,3, 1,4 diazines, that is pyridazine, pyrimidine and pyrazine. They are less basic compared with the corresponding pyridine. When we compare their basicity, these 3 compounds are less basic compared to pyridine. Similarly, the 2 nitrogen atoms in pyridazine, the 2 nitrogen atoms in pyrimidine, the 2 nitrogen atoms in pyrazine. All of them behave as the pyridine-like nitrogen atoms. So all of them are basic nitrogen atoms and both of them behave as the pyrimidine nitrogens. Now let us see the three diazines one by one. First, taking up pyridazine. In pyridazine, the 2 nitrogen atoms are in 1, 2 position. So pyridazine is one of the 3 possible isomeric diazines. That is 1, 2, 1, 3, 1, 4. So pyridazine is a 1, 2 diazine. In pyridazine, the 2 nitrogen atoms are present adjacent to each other. That is in 1, 2 positions. It was obtained in 1886 and was first synthesized only in the year 1895. So this is the structure of pyridazine and the numbering. So these 2 are resonance structures, resonance structure 1 and resonance structure 2. And coming to some of the physical properties of pyridazine. Pyridazine is a colorless liquid. It has a boiling point of 207 degrees centigrade and it is miscible with water as well as benzene. So the lone pair of electrons on nitrogen atoms are involved in hydrogen bond formation with protic solvents and benzene. So the nitrogen atoms are basic and we can add an electrophile to the nitrogen atom. But however, we can add only one hydrogen atom to one of the 2 nitrogen atoms and we cannot add simultaneously 2 electrophiles or protons. So it is a weakly basic compound and if electron donating groups are present, they will increase the basicity of the compound. Thus, pyridazine is less basic compared with 4-methyl pyridazine. So in the 4th position, if we introduce methyl group, it releases the electrons into the ring system and thereby the pyridazine will become more basic. So pyridazine possesses high dipole moment since the 2 nitrogen atoms in the ring system are placed on the same side. So higher dipole moment value is due to the fact that The two nitrogen atoms in pyridine are located on the same side in the ring. The two nitrogen atoms are on the same side, therefore there is greater pull of electrons to that side, and this results in high dipole moment. And the three double bonds that are present in the pyridine, they can be hydrogenated to form 6 possible reduced pyridines. However, only 3 of them are known. So this is 1,2-dihydropyridine. So the double bond present here has been hydrogenated, and this is 1,4-dihydropyridine. So position 1 and 4 are hydrogenated. This is 1,4-dihydropyridine, and this is 4,5-dihydropyridine. 4,4,5-dihydropyridine. So fourth and fifth positions are hydrogenated, and one double bond is missing here. There must be a double bond here. One double bond must be present here. One double bond here, another here, and the 4,5 carbons are hydrogenated. So coming to the methods of synthesis, there are three important methods of synthesis, and the fourth one is a benzo-fused pyridine. Synthesis of benzo-fused pyridine. We will see the first three methods. So from malic anhydride. First method is from malic anhydride, which itself is formed from a furan derivative. So condensation of hydrazine or its derivatives with malic anhydride results in the formation of pyridazine. Condensation of hydrazine and its derivatives with malic anhydride. So hydrazine condenses with malic anhydride. So this is malic anhydride reacting with hydrazine, resulting in the formation of an intermediate. So in the intermediate, the intermediate is treated with POCl3, where we place chlorines here. When these are OH groups, they can be displaced by the chlorine atoms. We get a dichloro 3,6-dichloro-pyridazine, which on dehalogenation gives the pyridazine. So the intermediate is refluxed. The intermediate is refluxed with phosphorus oxychloride to give a dichloro-pyridazine, which on subsequent dehalogenation with hydrogen over palladium and carbon gives pyridazine. So similarly, we can prepare some substituted pyridazine by this method. So this is methyl malic anhydride reacting with hydrazine. So then the resulting compound is treated with phosphorus oxychloride followed by dehalogenation to form a 4-ethyl 5-methyl pyridazine. So here the intermediate formed when a substituted malic anhydride is employed is called the dione intermediate. The second method is from the 1,4-dicarbonyl compounds. So it is not malic anhydride, it is the 1,4-dicarbonyl compounds that have been obtained from a substituted furan. So 1,4-dicarbonyl compounds reacts with hydrazine to form the pyridazine derivatives. So the 1,4-dicarbonyl compound itself is formed from a 2,5-dimethyl furan. So this 1,4-diketone is produced from the 2,5-dimethyl furan by treatment with lead tetraacetate followed by treatment with acetic acid to form a 1,4-diketone. 1, 2, 3, 4, diketone, which reacts with vinyl hydrogen in a condensation reaction using 2 molecules of water to form a 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 3,6 dimethyl pyridazine. So therefore, pyridazines can be prepared by the reaction of 1,4-diketones with hydrogen. That is the second method. Next, third method. From 1, 2, 4, 5 tetrazymes. So tetrazymes react with the alkynes in a cycloaddition reaction, and the resulting compound undergoes rearrangement to form a 1,2-diazine. So cycloaddition of 1, 2, 4, 5 tetrazyme with acetylenes or alkenes also results in the formation of pyridazines. So here we can see the reaction between a substituted 1, 2, 4, 5 tetrazyme with an acetylene, and the resulting compound undergoes loss of nitrogen to form the pyridazine derivative. These are the three important methods, and this fourth method is for the preparation of some benzo-fused pyridazines. So diazotization of orthoamino-phenyl propiolic acid followed by cyclization of the diazotized propiolic acid leads to the formation of 4-hydroxy-quinoline 3-carboxylic acid. It is a benzo-fused derivative of the pyridazine. So we can see here there is a amino group. This compound is orthoamino-phenyl propiolic acid. The primary amino group is subjected to diazotization. It is converted to a diazonium chloride. So which on keeping at room temperature overnight, it is undergoing cyclization to form a benzo-fused 1,2-diazine derivative. This is a method for the preparation of benzo-fused diazines. So this is another reaction. Another derivative can also be prepared by this method. So diazotization followed by keeping the resulting diazonium chloride overnight at room temperature, and then heating forms 4-hydroxy 6-nitrosinolene. These are some of the methods of preparing 1,2-diazones. The first three methods are giving only diazine derivative. The fourth method gives a benzo-fused diazine derivative. So chemical properties. Coming to the chemical properties, pyridazine is a weak base. So it is a weak base compared with pyridine, and it forms salts with mineral acids. When treated with mineral acid, it forms the corresponding salts. So the first one of the nitrogen atom gets protonated. Then the protonation of second nitrogen atom is difficult because of high energy required to generate the two possible charges on adjacent atoms. That means we can protonate only one nitrogen atom in the ring, because as the two nitrogen atoms are adjacent to each other, it is not possible to protonate both the nitrogen atoms because high energy is required to generate two positive charges on the adjacent atom, that is 1, 2 positions. So quaternization. Pyridazine ring reacts with alkyl halides in the presence of base to give monoquaternary salt. So here also only one of the nitrogen atoms, either N1 or N2, can only form the quaternary salt. So when treated with methyl iodide, only one of the nitrogen atoms can form quaternary salt. It is not possible to form quaternary salts with the two nitrogen atoms. Only one of them can form quaternary salt. So electrophilic substitutions. So 1, 3, 4 and 6 positions in pyridine are electron deficient due to the inductive effect of the nitrogen atoms. So the nitrogen atoms present in pyridine are like pyridine nitrogens. That means the nitrogen atoms are electron withdrawing in nature. Therefore, the entire ring becomes electron deficient. Therefore, pyridine is resistant to the electrophilic substitution, and, electrophilic substitution occur only under drastic conditions. So, as the ring is electropositive in nature, substitution of electrophile becomes difficult. So, however, appropriately substituted, if electron releasing groups are present in pyridine ring system on the carbon atoms, it will become more electron rich, and substituted pyridines may undergo electrophilic substitution. So simple pyridine, it does not undergo any sulfonation. It does not undergo sulfonation or nitration. So brominacetic acid is used for dehydrogenation of reduced pyridines. So reduced pyridines can be converted into pyridines by treatment with brominacetic acid. So bromination followed by dehydrohalogenation. The 3 and 4 chloropyridines are obtained by treatment with pyridinones with excess POCl3. Pyridinones, when treated with excess POCl3, they form 3 and 4 chloropyridines. So reaction with nucleophilic reagents. So pyridines are susceptible to the action of nucleophilic reagents as the ring is electropositive. So annihilation of 3,6-dichloropyridine takes place through powerful aromatic nucleophiles. So powerful aromatic nucleophiles like 3-aminophenol can react with 3,6-dichloropyridine to form a substituted product. So here the chlorine atom is displaced by the nitrogen. This NH2 is attacking as a base at the carbon atom. So it is a aromatic nucleophilic substitution. So this 3-aminophenol, it acts as a powerful nucleophile and it can displace this chlorine atom present in the ring system to form a substituted product. So it is a nucleophilic substitution reaction. So reaction with oxidizing reagents. So pyridine on reaction with hydrogen peroxide results in the formation of N-oxides of pyridine. Here also we can see only one of the nitrogen atom can form the N-oxide, not both. With silver nitrate and acid fluoride, we get, so when this N-oxide is treated with silver nitrate in presence of an acid fluoride like benzyl chloride, we get a 3-nitropyridine 1-oxide. So the 1-oxide can undergo nitration on treatment with silver nitride in benzyl chloride. So importance. These are some of the reactions of pyridine. So electrolytic substitutions are difficult. It can undergo some of the aromatic nucleophilic substitution reactions. It can form an oxide on treatment with hydrogen peroxide. Next, coming to the importance of pyridine. Pyridine and its fused heterocyclic derivatives have been used as antifungal, anti-cancer, herbicidal, and anti-inflammatory, anti-tubercular, anti-hypertensive, and as plant growth regulators. So various derivatives of pyridine have been used in medicine and also they have been used as various agricultural products. Several derivatives of pyridazine such as 1,2,4-triazole, imidazole, isoxazole have wide spectrum in biological and therapeutic areas. So 6 substituted and 2,6 disubstituted pyridazine derivatives show pharmacological profile as antiplatelet drugs. These anticoagulants. Antiplatelet drugs mean anticoagulants and also used in the treatment of cardiovascular diseases. 6-allyl thiothree aminopyridazine is used as an anti-cancer agent. So some of the substituted pyridazines have been used as anti-cancer agents. So some of the pyridazines have also been used as antihypertensive drugs such as hydralazine. So minaprine is used as the antidepressant. So they pyridazines have a wide range of biological activities and they have been used for the treatment of various diseases. This is about the synthesis and reactions and importance of pyridazines. This is one of the 3 possible azynes. So this is pyridazine is a 1,2-diazine.